So this is our second lecture. And here's the link to the video, which I created of our first lecture. And in this video and in that lecture, I didn't mean to click on it, but the focus was on understanding how the command line interface works in a Linux environment or a Unix environment, like Mac OS X, for instance. And then there's an assignment, and half of you have started this in the lab. You don't have to wait to go to the lab to start these assignments. You can do these assignments at any time. You don't have to be in the lab to do these. But you do have to be in the lab to take a quiz. And the first quiz will be on Wednesday. And just to get yourself ready for that, you should be looking at these example quiz questions and making sure that you know how to answer these. So we have a Monday holiday, so that's going to interfere with the way that we take the quizzes. So the people that met last time in that section, that you'll have your first quiz this coming Wednesday. And the people that are meeting today, in lab today, you're going to skip next week because next Monday's a holiday. So we have to wait till the week after Monday to take your first quiz. So I got to figure out how to make up for that missing time there. So I think at some point we'll need to take 2 quizzes in one lab session for the people meeting the second time. We'll figure that out as we get there. But the people that are meeting on Wednesday, you need to get ready for this this quiz. You should just go through this list and see if you understand how to do these problems. Let's take a look at some of these. What is the Unix command to display your current working directory? So that's an easy one. Print working directory, PWD, print working directory. I think I can put this tab up there, make more space. Also, there's a change I discovered yesterday or the day before. And it has to do with this setting here. Like this folder, it shows you this folder here. And it really represents the workspace, which is right here. It doesn't show you the home directory. The home directory, if I do CD enter, I go to the home directory, print working directory. I see that my home directory is /home/Ubuntu. And I'd like to see this display show, my home directory. So there's a setting for that. And I'll do show home in favorites. And so now I have 2 views here. And I'm going to turn off the other view, show the root file system. So workspace is the root file system. And this is, once again, this system is mainly for developing web applications or mobile applications or distributed applications where you have a server and you're writing code for the server side. And the root folder is like your public folder. That's the files and objects that can be retrieved from clients like browsers and mobile apps running remotely. So that's the reason for that. And now you'll see in this view, you see the tilde there. That's the special character that represents the home folder. And you can see there's a lib folder. Lib folder has an Apache 2 folder in it. That's a widely used web server called Apache version 2. Inside Apache 2, you've got some folders that are used by Apache, the Apache web server, and I don't see anything in there, but that's that. Then there's the workspace folder. So I'm going to move my work. I'm going to work in the home folder. Right. Actually, I wonder if I turn on collaboration, I think you can access my home folder. We should try that. Is there someone that's connected and can do an experiment? Okay, you're connected.
Yeah.
I think I can access your. What's your ID? Just give me 2 letters from it. Your ID.
For my user?
Which one?
For my user?
Yeah, your username, like Victor Herrera or Cody or
DU.
D. You.
You should be one of the personal.
Dustin.
Yeah.
Dustin 277. Let me share this with you. Try to go into the shared with me
Yeah,
area.
saw yours. Access.
So you can access my home folder, right? No problem, like inside
Yeah.
here. Can you create a file under here? Say main.cpp. Can you create that file?
Change anything. Oh,
Yeah, can try this. Do touch main.cpp. Touch main.cpp. Yeah, I'm not doing anything. Oh, MAI. Yeah, .cpp. So you created it. So, okay, I just wanted to see that other people could access I can access their home folders. I don't think there's any problem there. All right, that's good. I'm going to bump you out. No, let me leave you in there just in case. We'll try something together. So, Dustin, how about your ability to do these things? Can I put you on the spot there? And have you been studying this at all?
a little bit. I'm let's see, show Unix command to change the current directory to folder name SAM located in your home directory.
So I got to create a folder named Sam. Let me just do that, okay? So there's the SAM folder. So show the Unix command to change the current directory to a folder named SAM located in your home directory. Can you do that? See, right now, your current directory is home/Ubuntu. But we want to make your current directory home/Ubuntu/SAM. Yeah, that's good. You did it. That's it. You did it. If you do pwd, try pwd. That's print working directory. And it shows you the path to your current folder. See, that shows you the path to your current folder. That's good. So that's that one. And look, it says, make no assumptions about your current location. Oh, watch this. Okay. So make no assumptions about your current location. So, our current location is here. But I want to go to /home/ubuntu/sam. How do you do that with one command? How can you do that with the cd command? What argument does the cd command take to do this hop from the workspace folder to the SAM folder? Can you try it?
To try to go to the SAM folder.
Yeah, all in one command.
I still do CD SAM.
Well, that'll work if SAM's a subfolder of workspace, but it's not.
Okay.
See, you're typing in there is called a relative path. SAM is a relative path, and the system is looking for SAM, the folder SAM, in the current directory. But there is no SAM in the current directory. What's our current directory?
Workspace.
Workspace. Is SAM a child of workspace? No. SAM is a child of the home folder. So you need to use, you can use a relative path or an absolute path to get to SAM. You can use a different relative path. Anybody know how to do this?
So it'd be CD and you have to do tilde for the
Yeah.
folder, right? And you just do backslash.
You could try it like that. That's an absolute path. Just trying to, whoa, space.
Parentheses space.
Yeah.
And then SAM.
/SAM. There you go. That's an absolute path. And I'm going to do PWD. That's where we are now. But what about, I'm going to go back to that workspace, okay? Can you get to the SAM folder using a relative path, not an absolute path? Relative path, relative to your current folder. How do you get to SAM using a relative path? Anybody know? I'm going to give you a hint there. Look at the special symbols here. 3 special symbols. Dot is current directory. Dot dot is the parent directory. And tilde is the home directory. Tilde gives you an absolute path. But dot dot gives you a relative path. You start with a dot dot. Dot dot means the parent folder. So can you formulate another CD command that uses dot dot to get to SAM? So nobody in this class can pass the quiz on Wednesday. All right? That's the reason I'm doing this. You have to study this, yeah.
I'm not sure, but would it be cd.dot/sam?
Let's try it. CD.
Oh, CD. I don't have the CS.
Space.
Right, is there like a lag on
It works. That's how you do it. That's another way to get there. Good. PCBWD. That's good. All right, let's look at another one. And Dustin will keep you online there, okay?
Okay, I'm on it.
All right, so let's do number 3. Suppose you have a file named main.cpp that is in a folder in your home directory. Suppose that this folder is your current directory. Show the Unix command to copy main.cpp to your home directory. Let me set that up first. Okay, hold on there. So I'm going to use the touch command, which you don't need to know, okay? But you can, now you'll see that inside SAM is that file main.cpp, okay? Let's go back. Suppose you have a file named main.cpp that is in a folder. In this case, this folder is SAM. So main.cpp is in SAM, and SAM is in the home directory, so that's all set. Suppose that this folder is your current directory. It is right now, right? This is our current directory. Yeah, so you're doing the copy command already. So show the Unix command to copy main.cpp to your home directory. How do you do that? But you know, actually this is, we got one there already. We can overwrite it, not a problem. But we can overwrite it. The copy command will overwrite that, but I'm going to leave it out just so we see it appear. Right, go ahead. It works. You got it. Copy source to destination. So the thing that we want to copy, main.cpp, and that's a relative path to the main.cpp in our current directory. And the destination is the home folder. That's good. Now we're getting the hang of it. So you just do a few of these, and they all start to make sense. These are not hard, I got to tell you this. This is the easiest part of the class. Yeah.
So for like number 2, are you be more specific, like relative, you know what I mean, when you ask the question?
One more time.
You know how you said there's a relative path, and then you said there's the other way? So I mean, are the questions going to be more specific, or is it just?
No, they're going to look like these.
Okay.
They could be more specific. Yeah, be prepared for anything, really. If I say use a relative path, I never thought about it, that I could actually do that and ask questions. Thank you. Like for this, what Dustin did right here, okay? The destination is given with what, a relative path or an absolute path? Is that a relative path or absolute path? That's absolute, because it doesn't matter where your current folder is. Tilde always means home. That's it. So it's absolute. Can you change this, Dustin? Oh, no, go ahead. Help. Sorry.
Oh, sorry, I was just answering one of his questions.
No, go ahead. To help.
Okay.
I'll ask everyone else. Can you reformulate this command so that it uses a relative path for the destination? Well, let's suppose we get rid of this thing here. Can you use a relative path? Can you do the copy command with a relative path? How would you do it?
CP main.cpp, and then workspace.
Huh?
Would you say workspace?
Like that?
And then you would have to rename it, right?
But this is not going to work because workspace is not a subfolder of SAM. Workspace by itself, that's a relative path, but it implies that workspace is a subfolder of SAM. Actually, workspace doesn't exist as a subfolder of SAM. So what's going to happen here? We're going to create a copy of main.cpp, but the name of the copy will be workspace. But it won't be a folder, it'll be a file named workspace. See? We created a file named workspace, which is a copy of main.cpp. So this one didn't work. How can we use the copy command to copy main.cpp from our current folder, which is SAM, to our home directory? But don't use tilde. Don't use the absolute path tilde. Use something else. Yeah, right? Like our home directory is our parent. So we just copied up to the parent like that. Now we got it.
So how would you do it how do you format it if you want to copy something, so you have the name of the file you want to copy, but you also want to change its name? Where do you put the name relative to the file path?
Yeah, that's a good, actually that's one of the questions in here too. It's in there, all right, the question is in there. Let's suppose we want to copy it and rename it at the same time. So instead of main.cpp, we want to call it hello.cpp, okay? So we want to copy main.cpp from the SAM folder, but we want it to have a new name called hello.cpp. We just give the name like that. So we can rename it. The copy command lets us assign any name we like. If we just give it the destination, if we specify the destination as a folder, an existing folder, it'll copy the file with the same name into this existing folder. But if the folder doesn't exist, then it assumes that the thing is going to be copied and renamed. So you play around with these till you master these. This is great. If you can get these mastered, it's really good. Oh yeah, here it is, number 7 right there. Suppose you have a file named main.cpp. In your current directory, show the Unix command to create a copy of this file named test.cpp. The copy should go into your current directory. This is a test question from last quarter when I taught this. So I want to copy main.cpp to test.cpp, and I want the copy to go into my current folder, which is SAM. There it is. So source, destination. In the destination, there's no folder name in the destination. That means it's the current folder. So test.cpp goes in the current folder. So we've got to keep practice. You should practice these in the lab and at home. Because in the lab, part of the assignment is you go through the tutorial. But the tutorial is a lot deeper and more comprehensive than what you need to know for these quizzes and the final exam. So these questions here, these sample questions, as well as my description up here, these tables, will show you what you need to know for the exams. Of course, for your career is a different thing. You may need to know more for your career. And the tutorial, the online tutorial that I have you go through for the first assignment helps you learn more than what I'm showing you here. And these are fun. I got to tell you, these are fun. This is the easiest part of the class, so might as well get this figured out. So what I'd like to do is start talking about the elements of the C++ language. Unless people have a different idea what you want to do right now. No. So here's the, yeah.
I just have a quick question. What would you need to use the current directory for?
When would you use what?
Current directory, the dot?
CD? When would you use current directory?
Yeah, or no, I meant just the.
Oh, the dot?
The dot.
Yeah. Well, let me show you that one. That's a good question. Is there anything in this file? Nothing in there, right? Let's get this program. So I'm going to answer your question and also start in the new material at the same time. So here is a program. And all the program does is it prints hello. So where did I put that program? That's inside SAM, right? I'm going to remove test.cpp. I'm going to compile this main program. You see that when I compiled main, it generated a.out. That's the executable. If I do ls here, I'll see a.out. It's an asterisk, that means it's executable. So when I run this, so to run an executable, I want to tell the command line interpreter, run this program. This is this program is going to communicate through the console and the display. It's a console program. But when I try to issue the command to the terminal says it can't find it. I said, what do you mean you can't find it? It's right here. I talked about this last time, didn't I? Because there's this path variable. The command line interface, the command line interpreter, the program, this console program, when you give it a command, it looks in all the folders in this path. It tries to find the command there. But our current folder is not in the path, so it doesn't look in our current folder to find a.out. So we need to tell it that the a.out is in my current folder. So we give it an absolute path name. We can do tilde/sam/a.out. There it is. So now I gave it an absolute path name because a.out by itself is a relative path name. I give it an absolute path name to a.out and it runs it. And there's another way to do it. Well, because a.out is in my current folder. And you know this, we can use this symbol. Where's that symbol? We could use this symbol dot to represent the current directory. And here's the example right there, dot/a.out. So we tell the command line interpreter, look in the current folder, dot. And then you can find a.out there. So there's one example where you need a dot. Here's another example. See this hello.cpp? I want to copy hello.cpp into SAM. This is another example of using dot. I want to copy hello.cpp into the SAM folder. It's hard to see this down here. So, you know, if I go up, if I look at the contents of my parent, I see that hello.cpp is up there. And if I look at the contents of my current folder, I see that hello.cpp is not in my current folder, which is SAM. I want to make a copy of hello.cpp from my parent into my current folder. So go up to the parent. Now what do I give for a destination? So, you know, a copy source to destination. My source is /hello.cpp. And what do I give for a destination? Well, the destination, my current folder, right? What's the current folder? Huh? /. You can use /, yes. Or you can just use dot rather, not slash. You can use dot or you can use /. So there it is. So that's another example of when you would use dot. Okay. So it's used a lot, actually. Those three symbols are used a lot. And let's start looking at this. There was another thing I wanted to look at, just briefly here. This is a program that prints hello. We just saw that. And here's the same program, it just without the formatting. All the commands are there. You see the hello in there? And the cout, less than, less than. You know, it's the same as this. It's just that there's not many line breaks, there's not many spaces, but this specifies the same program that this one does. Well, that's just to show you that these line breaks and indents, see this indent here and the space between the T and that less than symbol, these are optional. They're not needed by the compiler to create the executable, but they're needed by humans to make the code more readable. So that's the point there. This code up here is a lot more readable than this code. Like this program is harder to read than this. Well, maybe right now they're equally hard for most of you. But in a very short time, one will be a lot easier than the other. So these programs have to be readable. These things like this, using namespace std, that's a directive or an instruction given to the compiler to do something. It says, you know, there's this namespace called std. There's this big collection of names. I want all the names in that big collection called std. I want all the names in std to be visible as you compile my code right now. That's what it says. So this is a directive that's acted on by the compiler. But this right here is a comment. This is only for humans to read. The compiler does not process this other than just skip over it. Just drops this. That's called a comment. This is a single line comment. It starts with a double slash. Now, if I had a single slash there, you'll see the color changed. And this is can no longer be compiled. Let me show you that. Actually, I want to put this back down here. See that? It's complaining about it. It's saying there's an error here. Error. This was not declared in this scope. And what's the slash here? It doesn't even know what to do there. And also the editor is displaying the text in black as opposed to green. So green is the color for, in this case, with this editor. Green is the color for a comment. You'll see that this text up here is also green. This is a multi-line comment. You start a multi-line comment with a slash star, and you end a multi-line comment with a star slash. And you could put these comments in many places. I could put it right here, for instance. It's just dropped by the compiler. The compiler will compile that. You can pretty much stick those comments anywhere you like, almost. See that? It compiles. And sometimes you'll see comments like this, but it's not a good place to put a comment.
What's general best practice? Like I know you mentioned in the syllabus it says like you should use comments sometimes.
Yeah.
Which makes sense. How frequently? I mean, like if your program is doing a few different things, should you be commenting out and explaining what you're doing in every step, or only if it's not like?
Well, it depends. It depends on your audience. You know, if it's a program that all of you are going to look at, I might put more comments in there. If it's a program that programmers are going to look at. This particular program probably wouldn't have any comments at all because they would just be a distraction. You only put them in there when needed. So you have to use your judgment. Like, for instance, this comment. You know, if you intended this program to be looked at by a C++ programmer, this comment would be harmful because it adds noise. A C++ programmer will just see that code and say, well, I'm printing hello. But here you're telling me I'm printing hello as well. So this is more to read. I got to read in 2 places to print hello when I only need to read in 1 place to print hello. Why tell me something I already know? But if you're not familiar with programming or the language, you could put that comment in there, and that would be meaningful to the reader of the code in that case. So once again, you have to use judgment. There's no hard and fast rule. Now, some instructors make hard and fast rules and say you've got to comment everything. Commenting is good practice, so just stick it in there. I think that's meaningless because for me, comments serve a purpose and to help make code more readable. But this code is less readable to a C++ programmer or even a beginning C++ programmer. You certainly don't need this. But if somehow you judge that as helping the readability of your code, then you could put it in there. It's very much a judgment thing. So this is the program. This is called a function here, the main function. This marks the entry point of your program. You can have lots of code in here. This is a tiny little 1-line program. But normally programs are very complicated. And you define this main function. This is where we're defining a main function because this tells the compiler where to start execution in your code. I could have another function here. Say hi. And that's a function. I'm going to call it, these are called functions. So my execution starts in main, and there's 1 line in main. It says, call the say hi function. That's the syntax for invoking the say hi function. So the execution will come up to say hi, and the system will execute that command to print hi. That's the command to print hi. So when the compiler looks at this program, like there's a command that says say hi here. Maybe there's a command here to say bye. So we have a command in line 10 that says display bye. That's actually called a statement. This is a C++ statement. Statements generally end with a semicolon, although they don't have to. This is kind of like a unit here. So this cout, arrow, arrow, by /n, that whole thing I've highlighted there as a statement. And this statement displays by in the console window. This statement displays hi. Now when you run this program, what happens? It says bye and then it says hi. Well, it didn't say hi first. But the statement that says hi is in line 6, which is an earlier line than line 10. So why does it say by first? Why doesn't it say hi first?
You're calling it after see out by?
Huh?
You're calling it after the statement of saying by?
Yeah. Well, the idea there is execution doesn't start here. Execution starts at the main function. Main is the entry point. So that's the purpose of main. Yep. That make sense? So when execution goes into main, it doesn't start up here. So we print by, then we invoke this function, say hi. Then execution jumps up to here, and then it prints hi. That's why we print by, then hi. Is that okay? All right. So main is the entry point. Now this topic here where like I'm defining a function, that's one of the later topics. It's here, meeting 3 functions. So it's coming in pretty soon. Now let's talk about these other basics like variables and types. What's a type? What's a variable? What does it mean to initialize a variable? And what's a string? A string is a type. And then operators. Let's cover all of those things. Let's see here. All right. So I'm going to take out this function. And I'm going to print OK. So this is how to print something. I want to say that this /n, this is a special character sequence that means a new line character. So you know when you're typing, like here on the keyboard, then I hit enter. When I hit enter, it generates a new line. See, that's what the /n means. It's like hitting the enter key. So when you see \n, it means something like hitting the enter key. And there, sometimes you see it this way, and sometimes you see it this way. End line. So this is a symbol that means to output a new line character and also do this thing called flushing the output buffer. But we don't have to talk about that too much right now. Yeah?
Can we not just put the end line after OK?
Yeah, that's right. We could do it up there. We can cascade it. So we do it like this. First, we print OK, and then we print the new line character.
So you
Now,
have to have the list then?
Huh?
You have to have the list then?
Yeah, you got to have that. This is not acceptable. Error. Semicolon expected before endl. Put that back in there. Now we're okay. But you know, if you look at this, how does let me explain this to you. This is getting out of sequence a little bit. This command here is to print OK. And then the next command is to print the new line. Or the next statement. I'm going to call those statements. So this is good. See how that works? Now let's take this one out. So if I comment it out, it'll be ignored. / starts a comment. Save that. Now what happens when we run that? We're printing O and K, but we're not printing the new line character. Look, you see the OK? And then immediately the prompt is displayed because we didn't hit the new line. So that it's, that's one reason you want to have it in there. at the end. Now this is an expression right there. I'm omitting this for now. This is an expression. It's an output operation. Less than is called an operator. It's an operator. You know, and operations, just like plus, you know, 2 plus 3. This is an operator. It has a left-hand side and a right-hand side. And this whole thing evaluates to something. It evaluates to 5. Right? The same is here. This is an output operator. It has a left-hand side. It has a right-hand side. And the whole thing, after it executes, after it is evaluated, it resolves to, or it becomes a new value. It evaluates to something new. And what I have highlighted right here, this evaluates to, it evaluates to cout. So this expression, and I can put parentheses around expressions. This is okay. This expression inside the parentheses, it runs and it sends OK to the output stream. It's displayed in the console. And then the whole expression itself transforms into just cout. So we say that it evaluates to cout. So what can you do with cout? Well, cout can function as the left-hand side of an output operator. See that? So this evaluates to cout so that it can become the left-hand side of the output operator. That's how you get cascading. That's why we can cascade these things. Each time you use this output operator, the result evaluates to the left-hand side. So this thing, this expression evaluates to its left-hand side, which is cout. So this whole thing is cout. And then that becomes the left-hand side of the next output operation. So the left-hand, so this whole thing evaluates the cout. And it becomes, so we can just keep cascading it. That's how you read that. I'm trying to show you how to read it.
So when you're doing that, like, is cout changing every time? Like, is cout okay, and then it's end line, and then it's okay again? Or at the end of that, is cout okay, end line, okay again, end line? Like, is it overwriting what's there before every time you cascade?
It's, yeah, I think the way you can think about it is that this, I'm going to take these parentheses. You could do it like this. Let me try to answer that. Like, if you look at how the parentheses would work, it would look something like this. See that? You know, it's like in math, the parentheses are used to tell you the order of things. Like I want 1 plus 2 times 3, because I need that. If I just do 1 plus 2 times 3 without the parentheses, I wouldn't get the right order. I'm just showing explicitly what the order is. This thing is first evaluated. And that whole thing evaluates the cout itself. It doesn't, I guess you can think of it as writing over it. I mean, if you want to use that as your mental model to understand what's going on, you can use that. And maybe later.
Is cout like a variable where, like, at any given time, like okay is assigned to cout and then something else is assigned to it?
Well, cout, I wouldn't call cout a variable. I would call it Well, it is a variable actually, yeah. But we're not assigning it. Assignment is an operation. So if we did cout equals OK, that's assigning the variable cout with the value OK. That's not what's happening here. Like if I did x equals 0, I'm assigning 0 to x. X changes. I compare that to this. Well, now I'm going to do a better one. X plus 1, okay? X equals 1 is changing the value of what x represents. That's done through what's called the assignment operation, assignment operator. But if I did this, x plus 1, does this modify what x is? No, it uses x. It reaches into x and gets whatever x is and adds 1 to it. And this whole thing, if x happened, so, this expression evaluates to 2 because x is set to 1 here. And then we use x in the next expression to compute, x plus 1. The expression evaluates to 2, but x doesn't become 2. So if I did cout x, I'm going to do this. This is the next one. So I need to declare it like that. X is an integer. And I'm going to set x to 1. So I need to declare x as an integer. I say x is an integer variable, holds an integer value. Then I assign 1 into x. I give it a value. And x plus 1 evaluates to 2, but this evaluates to 2, and then the 2 is just evaporates. It doesn't modify x. So here we're going to print, we're just going to print 1. Because in this line we changed x through an assignment operation. In this line we only use x as part of evaluating some expression. In the same way, this output operation does not modify what cout represents. Cout represents the output stream. This is an operation just like plus is an operation. I mean, in a sense, it modifies cout, in the sense that cout is a name that represents the console down here. And we're sending the number 1 into it. So we're modifying, this output stream. Cout's the name of this output stream, which gets to the console. But cout still represents the same output stream that existed before the operation. Does that make sense? That this is an operation. This is more like this plus operation. It uses cout, but it doesn't modify cout. See, this plus uses x, but it doesn't modify x. X plus 1.
If on another line you just did cout semicolon, you wouldn't get 1 again because cout would not. You haven't assigned anything. Like if after that you did another cout and it would just be blank.
Like this? Is that what you mean?
No, if it was if that second line was just cout semicolon, you wouldn't then get
This one here? Wait.
Second one, no, line 10.
Yeah.
If it was just cout semicolon, you wouldn't get the same output as the line above because the line above
This
changed,
like that, right? Yeah. Oh yeah, this will do nothing.
Yeah.
Watch this. I'll take this out, okay? So this does nothing. It prints nothing. Just nothing. We're just, this is an expression, it evaluates to itself, and then it just kind of evaporates, it's discarded. This has no effect either. This has no effect on anything. It evaluates to 2, and then the 2 is discarded. We're not making use of it. If we want to make use of it, we've got to do something like this. All right, here's my question. What's this program going to print? 2. Good. Now, what's this program going to print?
2 and then 1, right?
Everybody clear on that? Everybody has a solid answer to this? 2 and 1. Why doesn't it print 2 and 2? Because we added 1 to x here, didn't we? So why doesn't it print 2? Because this is the expression evaluates x is assigned 1 in line 7. And this expression, when it runs, it evaluates to 2, but it does not modify x. It just reads from x. It uses x without changing x. So if we use it here, we're going to use x again here, but we didn't. When we're using x in these cases, we're not modifying it. All right, that's how you think about that. Yeah.
But it still work if you initialize x on line 6 next to the weighted paired x integer.
We can initialize it there. Was that your question?
I thought I was just wondering.
Yeah, this is how you might normally, I would normally do it like this. This is called declaring x, and this is setting it to 1. So doing 2 things at one time. We're declaring x, bringing it into existence, and assigning it the value of 1. Now this will not work. The compiler is going to complain. It'll say, I don't know what x is. X was not declared in this scope, so we need to declare it. We say x is an integer. And then now it's okay. Or I could say x is not an integer, it's a double precision floating point number, double x. Look at that. That's okay. There's all these different data types. Float, that's single precision. That's floating point number x occupying 4 bytes of memory. A double is the same thing, a floating point number, but it's occupying 8 bytes of memory. So you get more precision. Yeah.
Now, will we still use doubles since they're so large?
Do it again.
Will we need to use doubles since they're so large?
Normally you just use double because float, you lose some precision. If you're using data with a decimal point in it, float is sometimes not precise enough. But a double takes up twice as much memory. So if you've got 1 item or 100 items or 1,000 items, so what, right? But if you got, 1,000,000 numbers, then you can say, well, I'm going to cut back on the memory I'm using by using a float. If your application can tolerate that lower level of precision, then it's smart for you to use floats instead of doubles.
Could we run faster?
So like in video games, or multimedia applications that have, like animation and graphics, the data is normally stored in floats to cut the memory consumption in half. But in like a an accounting application, you know, you're not going to represent money with a float because you'll end up losing, you might lose pennies, you know, here and there. Yeah. Okay.
Yeah.
That's, so this thing is called a data type. There's another data type. These are numeric data types. There's Char. And I think that will, let's see what it does. It does prints nothing here? I don't get it. So that's Char, right? It's not interesting. You know, I don't want to get into this because I don't have a quick answer for that, but you know, it's interpreting that X as a char. I'm going to say it's an int. I don't know why it just prints a 2 here. Why does it print a 2 there? Oh, because this whole thing becomes an integer. So if I made this a char, something like that, still, anyway. You see what I'm doing? I'm playing around, right? Because I don't know what's going on, and I'm starting to play around. But you got to start doing that. You got to start playing around, and that's to test your knowledge. Yeah.
So we can create a second, like a practice workspace.
Yeah.
CSE 201 practice, and then you can access both of those. Or
Yeah. You should go ahead and use your workspace, the one that you created for the course. You can go ahead and use that for practice.
oh, I mean, because you might accidentally delete something, and then you wouldn't be able to get it back, right?
You know, well, there's nothing. I wouldn't worry too much. Well, yeah, you need to be careful. If you delete something, you could. Yeah, go ahead. Make a second workspace. You can go to here and just create another project. And you know, CS201 alt.
Can you just clone it?
Huh?
When that's up there.
Can you do what?
See where it says clone next to the host?
Yeah, you could clone too. Sure. Yeah, go ahead. Try that as well. It's good. Yeah, that's what you do. Just jump right in there and just start doing stuff. Yeah, and then be careful. If you delete something, and then you're gonna have to recreate it. Yeah, that's the way to do it. Just jump right in there and start hammering away. Yeah.
What would you put for if you want to output letters, like names?
One more time.
What would you put? Would you still declare it? Like, say I wanted to put a name, declare it, and I put a name there for some reason, and output a name, but instead of put an X.
Can you type it in there as an example?
Yeah. Oh, I can't type on the top part.
No, you can. You can.
It's not showing me at all.
Double click this hello. Double click main.cpp.
Oh wait.
Does it come up?
I don't understand.
Should see you in there.
Oh yeah, here it is. Let's see. Like I wanted X, and then I wanted to make X like a name. It's like a character.
Yeah, let's suppose you want to print your name, okay? This is a very good question. It's great. Thank you very much for doing this. Now this will not compile. Let's try to compile it. You need to save it, I see it, and then try to compile it down here. And then down here. In there, can you compile?
Sorry, it's not giving me the options on the bottom.
Just click down here.
Yeah, I know it doesn't show me. I don't have the bottom half.
You don't have this?
You can just click there.
Open up, hit this plus sign here.
Yeah.
Oh no, you have it up here, don't you? You just drag it down there. See, you have it like up there maybe?
Oh, okay.
And drag it down here.
Oh, yeah. Yeah, that works.
there we go. There it is. Dustin was not declared in this scope. See, what you need to do, this is a string. You got to put quotes around it. See that? Now it's a string. But it still won't work. Let's try that. Invalid conversion from const char pointer to char. So you can't, a char is only one character. You're trying to put several characters into one character. So you're going to change this data type to string. Why don't you try to change that? That's it. Let's try to compile now. I'm saving there for you.
Sorry.
That works. Now let's run it. There it is. So that's called, X is now declared as a string data type. You can put all that in one line. Do you want to show all of that in one line, declaring X as a string and initializing it, Dustin, all in one statement?
Yeah.
Go ahead and let's do that. Good.
And want me to run it.
Yeah, no, I would have put spaces around the equal sign. That's an operator. We have spaces around this other operator. So let's be consistent in our formatting. If we're going to put spaces around our operators, let's be consistent. Put spaces around all of our operators. You know, if you don't like it like that, but that would be that's more consistent than the way you just had it. Yeah, let's try that. Don't forget to save. I see, there it is. I saw that turn to an X. I know it's saved. Now we're down here. Dustin, that's great.
So at the end del, you can use a slash and an N also, right?
This endl,
Yeah, you can change that to a slash and N, right?
you can use it instead of the slash n. Or if you wanted to use slash n here, you could do that. I give you the same result. ENDL is only in C++ language. But the \n is in every language. So this is better to learn because you'll see that in any language you're working in. Normally they'll use that as a way to represent a new line character.
So why do they have quotations now?
Huh?
How can you put in quotations slash N?
We need quotations around the slash n because we have to tell it that it's a string. We could also use, this won't work. That's not going to work. It doesn't understand that. We have to tell it that it's a string. This is a string with one character in it. But you know what? We could also tell it it's a character. If we use apostrophes, this is acceptable because \n is a single character, and you use apostrophes to designate a single characters. See, now that's all right. Like I could do a char, I'll say new line. You see the difference there? So I'm declaring new line as a variable of type char or character. And setting it to the new line character. It's a single character. So then we just print it like that. Now you couldn't do this because this is not a single character anymore. It's two characters. So that won't work. Warning, multi-character character constant. So it should only be one character in there. That's one character. I mean, we could put a P in there. That's all right. That'll take it. Whoops. Here's Dustin P right there, but now we're not printing the new line anymore.
You're just like declaring a variable and you're calling it right there as the CL, right?
Yeah. Say it again.
At 7, you're declaring a variable, and then at 8, you're calling that variable, right?
Yeah, that's right. So in line 7, we declare the variable new line, and we initialize it. And then in line 8, we use that variable. That's what you said, right? Just repeating for the video. Let's see if there's anything else we need to cover here. These are the different types. There's a size of operation that you can play with. You need to read this, by the way. It's not a lot to read. It's a tiny bit to read. And this is variable initialization. Here we have strings. And then we have the assignment operator. We have these arithmetic operators. We need to talk about those. And do we have time, or should we do it next time? Maybe next time. Well, if you can remind me, next time we meet, we'll talk about the arithmetic operators. Okay, so that's it. Yeah, one more.
We only use strings for characters, right?
We don't.
Using strings in that one.
We use the quote for a string variable, and we use an apostrophe for a char variable. Is that all right?
So string for characters.
String is for characters,
Okay.
multiple characters. A char is for one character. So they're both for characters.